Hello and welcome to the Red Mars podcast. Once again, I am AstroJake and I am here to walk you through some fun stories that are currently going on in the space community. So today we have quite a few good ones. This is more or less just kind of some stories I've come across that have come back to light, and some of these are new and just really interesting. And then I want to focus in on the specifics on something known as DSOC. So we'll get into that in a moment. I got some notes that we'll talk through as well. But this topic really goes in line with what we were talking about in the last episode, and that is the wireless transmission of power. We're going to talk about it in terms of energy in this one, specifically communications, and what NASA is doing for deep space communications using laser beams. Super cool, but before we get into that, I want to start with some just cool topics that are currently going around. So we're going to talk about ExoMars Rovers. We're going to talk about, again, some nuclear propulsion that's coming into play more recent than you may think. And we're going to talk about going to the Hilton Hotel in orbit and something called StarLab. Very cool. Now, before I get started, I just want to say I apologize if there's any weird audio. My AC kicked on right before I was doing this, and I'm down in Florida where it is hot, and therefore I want to keep the AC on. So if there's some background noise, I do apologize, but hopefully you'll be able to hear me just fine as we get through this. So for those that are watching this in YouTube here for the actual video itself, again, this is a video podcast with the audio that I'll separate out and upload for those that are listening only, and that goes back to Spotify and all those other podcast listening, I guess, platforms. But for those that are watching, I have a few browsers open here as usual so that I can go through what these topics are, give you some feedback or some background on them, and then we're actually going to do a fun live, well, it's not really live, but live during the recording of this episode, exercise where we're going to use some AI so I can show how you can use AI as a great tool for learning and trying out some experiments that you might not have the largest background on. So I use AI for many things in my day-to-day life. If I'm trying to learn a new skill or try a new technology, AI is a great way to really utilize a plethora of knowledge and resources all in one spot. Now, there is a downfall to it. We'll get into that. But without further ado, let's get into it. All right. I mentioned we were going to talk about the ExoMars Rover. So what is that? So that is a rover that the European Space Agency is working on. I believe this is actually developed in the UK, which is kind of neat. And for those that live in the UK, I'm sure you'll say everything is invented in the UK, but no, that's just a joke. But yeah, this is a very good example of other countries in the world that are contributing to exploration of Mars, and then the ESA has been very much involved in that. And so this rover is actually looking for the signs of life on Mars from the past. So not any current existing life. We haven't been able to find any. Not saying that doesn't exist, but there's no evidence of current life on Mars. But there's quite possibly a past of the red planet that shows that there could have been living organisms on the surface. And so this rover is actually going to dig down about 2 meters. And for those that don't use the metric system, 2 meters is roughly 6 feet-ish, and our 2 yards. Those are close enough together that we can say they're more or less the same for this talk. But yeah, so it's going to dig down about 2 meters or so and look for signs or remnants of ancient life or past life that could have been living or roaming the surface of the planet. Now, going onto my sci-fi tangent as always, it would be super interesting, and I won't say cool because it would be kind of disturbing, but if they found remnants of human life on Mars, that would go to some of those conspiracy theories that, hey, we started there first, destroyed it, and came to Earth. So we'll see what happens. Should be interesting. If they ever found that, who knows when we'd actually find this, or if they'd ever release this to the public, who knows. But this isn't a channel on conspiracy theories. We are trying to stick to facts. So with that is the ExoMars Rover. This is from the European Space Agency's website. So if you go to the esa.int, you can go in there, search up ExoMars. You can even just do a Google search if you want. Look up ExoMars Rover. It's one of the first ones that comes up. And this will walk you through what this rover actually is and what its purpose is going to be on the red planet. So this goes through, there's more things that you can go through, the driving modes, landing site, fact sheet, and all that. But we're not here to go into all those details on these Mars rovers. We can save that for another podcast because our main topic is DSOC for today. So before we get there, I mentioned booking a hotel room at the Hilton and spending your evenings watching the sunset behind the beautiful blue crest of Earth. That's right, in orbit. So what is going on there? Well, if you go to Hilton's website and do a search for StarLab, you'll find something quite cool. Now, this is an older article back in October 16, 2024, but this is getting light again because the International Space Station is getting old. What that means is we're going to need a new contender to do research and observe the Earth. So there's many contenders out there, many companies, private companies that are looking to be the replacement for the International Space Station, and specifically, I believe that's going to Orbital Reef, which is paired with Blue Origin, but there are other companies out there as well. Now, SpaceX is going to be the launch vehicle, specifically the Starship, for putting the StarLab up into space. Now, I do expect other companies and billionaires out there that are in the travel and tourism to get their hands on some of the action and work their way into orbit as well. I wouldn't be surprised if Richard Branson already has a plan there. And if you do know about a plan or you have others there, definitely feel free to throw those comments in the comment section and let me know what's going on and what's out there. So, really hard to stay on top of everything. The world is changing extremely fast. The space community is growing ever so quickly as well. And so it's super exciting to have all these come in, but it makes it super hard to see everything that is happening. So I try to periodically look at what's the top stories going on, what's in the headlines, and then share those with you. So, Hilton. All right, so on this page here, this is on the Hilton's website. So again, go to hilton.com, look up StarLab, you'll find this article here. And the headline here, for those that are listening, is Hilton, Voyager Space, and StarLab Space share the first fly-through video of StarLab Space Station at the International Astronautical Congress. So that's why this was back end of last year. Now, there's a video here. I am going to turn the volume down because last time I did this, it turns out the audio coming through was actually quite significant and overpowering. So we'll start with no audio. We'll play through a little bit of this so you can get an idea of what this StarLab Hilton Hotel in orbit will look like. All right, so the video itself, it looks more or less like your average space station until you get inside and have the luxurious cabins and community spaces and stuff like that. Some very fancy looking panels. You have your typical what would look like a first class seat on an airplane with your own kind of cabin, and there's several of these around the station. And as this video goes through, I can read through the paragraph here. Let me see if I can get it so both are on the screen at the same time. Good enough. All right, so a pioneering partnership announced in 2002, the collaboration between Hilton and Voyager Space aims to bring unparalleled comfort to their state-of-the-art scientific discovery and crew habitation spaces aboard StarLab. The new station, operated through a U.S.-led global joint venture between Voyager Space, Airbus, Mitsubishi Corporation, and MDA Space, is a free-flying commercial space station that will benefit from Hilton's expertise in hospitality and design. Hilton's partnership will ensure that every stage of the astronaut's journey, from ground preparations to in-space living and the return to Earth, is infused with comfort and hospitality. How about that? So inside StarLab, for those that are unable to see, this is their description of what is unveiled in the actual fly-through video. So, the fly-through video revealed several key areas within the StarLab space station, including crew communal areas, wellness spaces, and advanced sleeping quarters. Larry Traxler, Senior Vice President, Global Design Services, Hilton, expressed his excitement about the progress that had been made in the project over the past 2 years. The first look at StarLab project is just a sneak peek at the exciting progress we've made in research and design over the past 2 years. Traxler said, "Our team is enthusiastic about the future of human space exploration and how hospitality has an opportunity to touch it all, from pre-flight training to the in-space experience to our guests' return to Earth." Super exciting. And I think that's super cool because space should be available to everyone. And there are many companies that are trying to do this, and we need more. You know, one company is not going to be able to do the heavy lifting for everyone. You need competition, and that's the only way you're going to get costs down. So, the more startup companies we see, other hotel companies, partnerships, and all that come together to build these services that are going to make access to space available for people like you and me that are, not billionaires, but have the ability to, say, buy a plane ticket from here to another country. Maybe that same cost will soon be what it is costing to go to space. Obviously, this is down the line, possibly not even in my lifetime, but I do hope so, as I'd love to go to space. Now, I do work for a space company, as I've mentioned many times before, and if opportunities do arise in that field, I would definitely like to take it, or if another astronaut recruitment opens up, then I will definitely hop on that as well. But until those days, I look forward to affordable space travel. So that is the StarLab. So moving on, so I don't spend too much time on these, otherwise I'll talk everyone's ear off for way too long. We're going to talk about the NASA DARPA test of the nuclear engine for future Mars missions. So I've mentioned this one before, and so I won't go too much into detail on this one, but it's just the key point here that I want to make is that the test for this nuclear propulsion engine is actually scheduled for 2027, which is much sooner than you may have imagined for such technology. So these sci-fi technologies, like I mentioned, are definitely becoming a reality sooner than later. Now, with that, I did forget to mention the ExoMars and the Hilton StarLab is actually looking to launch both of those, I believe, in 2028. And I did mention that Starship is going to be the heavy lift vehicle for StarLab. And so, again, that's super exciting. Now, there are other space stations that are looking to go up. They're just taking a step back for a second here. And I forget the company names, and actually I might have it in my notes here. So if you bear with me 1 second. Let's see. Space habitation. What did I have here? We have StarLab, mentioned that. Voyager Station. Right, so Voyager Station, which I think I mentioned in the Hilton one as well. But the idea behind this is to provide a rotating space station that allows the simulation of gravity of Earth. So for those that are not as accustomed to the zero gravity environment, this gives you a much more comfortable, familiar feel to your travels in space. So it's one of the main ways they've been looking at giving an artificial gravity is through the rotation, and pretty much you spin it to a velocity that would simulate the centripetal force equivalent to gravity, and you would walk along the outsides of it in that circular shape. Now, it's actually an interesting one. Looking at other missions that have done this, a more recent mission on New Shepard, Blue Origin's New Shepard rocket, did a very similar test, I guess, really, just on a much smaller scale to simulate lunar gravity, so they could test out some lunar payloads for their lunar team, and that is super exciting, and I encourage you to go watch that on blueorigin.com. You can watch a recap of, I believe that is NS23, if I'm not mistaken. So go check that one out. All right. So yes, back to the nuclear propulsion. Planning to test as soon as 2027. There's a render here on the screen of what their rocket could look like. I assume that this would be much different, but that's the concept drawing as it sits right now. I definitely look forward to seeing more about this. There's a lot more information on here, but because we've gone into detail about these types of propulsion devices in the past in other episodes, I won't go too much into detail here. So that brings us to our DSOC topic here, Deep Space Optical Communications. And the reason I want this to be the main topic, and I really found this one super interesting, is because we talked about the transmission of wireless energy or wireless power. Now, depending on how you think about this, this is really the exact same thing. The light that is being transferred here is technically an energy source that could be used for powering spacecraft or powering devices. Now, the difference is they're using the energy medium to be a transmission of communications. So think of a laser communications device, but for space. And so the Deep Space Optical Communication Network is currently being developed by NASA, and this is going to be similar to how they have the DSN, which is the Deep Space Network, but an alternative to radio frequency or RF communications. Now, we mentioned in a previous episode those different bandwidths that are allocated. So we talked about Ka, S-band, UHF, and all these different frequencies that are used for different uplinks, downlinks, telemetry, communications, and whatnot. And those are very useful, but present a problem in itself right there, is that you have allocations of bandwidth that you are limited to that means you have a limit or a finite amount of data that you can pass between the top and bottom. So think of a bandwidth as your waveform. You go up to a certain amplitude, down, and that you can squish as much data as you can in those finite, limits. Now, when you're working with a laser beam, you have a lot more bandwidth in a smaller area, and you're not sharing that with anyone. Now, you might break up allocations in your network for different types of devices and stuff like that, sure, but think of it, I guess, as another way of looking at this would be an optic connection for like fiber optic. Think at your home you have fiber optic internet or something like that. What that is a small glass tube that you shine light through. And the reason it's so fast is because, well, not only it's moving at the speed of light, but because you can fit so much more bandwidth in that concentrated beam of light. Take the glass tube away and focus a beam from point A to point B. As long as nothing steps in between you, well, then you have similar communication, just not passing through that fiber optic cable. So obviously that simplifies this whole thing. It's a lot more sophisticated than that, but trying to paint a picture of what it looks like. So I'll read the headline here that NASA has for their active mission, or for their mission description here. So NASA's DSOC experiment is the agency's first demonstration of optical communications beyond the Earth-Moon system. DSOC is a system that consists of a flight laser transceiver. Transceiver just means transmit and receive. A ground laser transmitter, so it only transmits, and then a ground laser receiver. They split them out on the ground, and there's a reason for that. And the new advanced technologies have been implemented in each of these elements. So this is a communications device that would be placed on top of other satellites that need to communicate as part of that network, and each one more or less becomes a relay as part of a larger mesh system in space. And now, the reason that laser is so much better, and I'll say better than RF, is because it is inherently better at, less prone to being affected by interference, which you get a lot with RF because the cosmic space environment is just full of radiation, and that radiation interferes with RF communications. Along with that, RF communications over long distances spread out, which means you have a much weaker signal at the receiving end, whereas a laser beam, you can really focus it so that you don't have as much dissipation over distance. Think of it as think of a pool, and you throw a rock in a pool and you see the ripples come out. The ripples are very strong right next to where that rock was, but by the time you get to the edge of the pool, that ripple's not as strong anymore. Now think about if you have a laser pointer. When I take a laser pointer and I go and, well, you shouldn't do this, but shine it at your neighbor's house, that laser beam is pretty much just as bright on the neighbor's house, as it is as if you shine it at your foot. And that is because it is a very concentrated beam of energy that allows you to do this. Now, obviously, lasers can be dangerous. There's some really high-powered ones that will catch things on fire almost instantly. So don't do these experiments at home. Know the safety precautions to take with them. But yeah, so I hope that gives a kind of understanding of the differences, the very high-level differences of why they would choose laser over RF. Now, there are downfalls to it. RF can pass through a wall. A laser beam cannot. So you have issues here. It's, what happens if you need to send a communication and an asteroid gets in your way, or a planet is in your path, or something like that? Well, that is why you need to build a mesh. So that is a network of these satellites flying around in different orbits at different apogees, so that they can transmit and work around these different obstacles. Now you also have the issue of obscurities. Obscurities being, say, like a dust storm, for if it's trying to communicate with something on the surface of Mars, where dust storms are prominent and can happen quite frequently. Well, that can cause the laser to get distorted and lose a clean connection. With that, they have implemented a caching mechanism, which more or less stores the data that it was going to transmit and waits for a clean connection to open up again, and then continues on where it left off. Now, RF might not have as much of an issue. There'd definitely be some sort of interference with something like that, especially if you get dust on the transmitting antenna or receiving antenna or something along those lines. However, you have the distance issue again and strength of signal, whereas the laser outweighs that. So this is why they're experimenting with this and seeing what they can do. Let's see, what other facts can we say about this? Let's not go to that one. Let me just go through. I got some notes here on this one as well. Just want to make sure I covered everything because the DSOC network's quite cool. We've talked about bandwidth. Yes, this has been demonstrated already at a distance of 140 million miles, about 225 million kilometers. And actually, fun fact about this, they mentioned in here that this was the first time that they're doing this demonstration beyond Earth-Moon system. Now, fun fact about Earth-Moon, and I don't know if many of you know this, but they actually would shine a light or a laser from Earth to the Moon and reflect it back. And they've been doing this since, I believe, pre-Apollo. Whenever they first started sending probes to the Moon, they've been able to, on a very small, I don't remember the exact dimension, so definitely let me know, or if you look this up or you know the answer to this. I could look it up right now, but I won't do that while on this call. But yeah, so they would have a small disk, they'd shine a laser and shine it back, and that's how they could measure the distance and the time it takes for light to travel to and from. And obviously they could do it without these lasers, but a laser is a very precise way of saying this is how long it takes light to get from one point to another and then back, and they can measure that return trip. And they've actually used this to help determine that the Moon is slowly drifting away from Earth, which is a whole other story that we could talk about. But that's the DSOC network. And one other cool, interesting thing about DSOC and its technology is this was actually proposed for something called Li-Fi many years ago, which was supposed to be an alternate to a Wi-Fi. Now, it hasn't been taken off, and probably for good reason, is the use case of a Li-Fi network. The public would probably want to use this the same as their Wi-Fi, whereas maybe they're in the garage, maybe they're in the backyard, maybe they're walking around, and they want to be able to have that seamless communication with their devices so that if they're watching a video on their phone and they step outside for a second, they don't lose their connectivity. Well, lasers are line of sight. So the way that I think they were planning to do this, and I could be wrong, but I know that there's some of these designs that came out, might have not been the main one, but they had like a light bulb, and that light bulb would act as almost like a laser disco. And now the guess wavelength that they were looking at was near infrared, which is the same as what the DSOC is looking at using as well. And the reason they look at near infrared is because it does best through obscurity. So you can use this on Earth to space, so through the atmosphere. And near infrared is a wavelength that doesn't have as much interference with the different layers in our atmosphere, whereas, say, visible light does. Or a good example of this is if you look at the stars at night, you'll usually see a twinkle or something that's happening to that star, or maybe it blurs a bit, or it becomes brighter, then dimmer, brighter, and dimmer, and all this you're seeing is interference from the atmosphere. Really, it's just shining. So the same thing happens when you're trying to do communication. If you're trying to send a message using light, and you're doing that through, modulation and coding and stuff like that, the atmosphere could definitely cause errors in your bit sequence or your encoded data. And so obviously you use things like error correcting code and stuff like that. And this will come back to the Li-Fi discussion in a second, and I'll link it back there. But yeah, so this wavelength is the most effective one at getting through, or I guess balance at getting through obscurities, and outweighs the other wavelengths that are available to use. So near infrared is the one that was chosen for the DSOC network, and it was the one that was used for this. Now, infrared has been used for, think of your remote control on an old TV. You'd have a little LED, it looks like, on the end, which is a little bulb, I guess, if you're thinking of it. It's called a light emitting diode. That would be at the end, and you'd have a receiver on your TV. You would put in your keys, and the TV would react. And that's the same thing. It's a point-to-point line of sight light signal that it picks up. And the infrared on that wasn't too focused, so it would spread out a bit, and that's why you didn't have to point it directly at your TV, and the TV would still get us because that beam of light would spread out, kind of like how your flashlight does. It wasn't really focused. Now, if it was super focused, that would be super annoying, because if you weren't able to see it, which humans cannot see near infrared, you wouldn't know where you're actually pointing. You'd have to point it, and you might be off by a few millimeters to the left or to the right or above or whatever, and your TV wouldn't see the signal. So you don't want it super focused either. So there's a happy medium between that. So tying this back to the Li-Fi instead of Wi-Fi, that's your light network, same thing kind of applies here. you have all these little beams, and obviously you're not going to have laser beams because if it's too focused, it's not going to cover the area you need it to receive it, but it's line of sight. So if I go outside and this bulb or transmitter transceiver device is inside my house, well, my phone's no longer going to get that internet connection. Same thing would be as if you have these blind spots in your house. Think of, a shaded corner in your house where the light doesn't really get, or in the closet or something like that. Or you have a device in a shelf that you maybe have a game console or something like that. Well, if it doesn't have a direct line of sight with that bulb, or it's in a cabinet or something like that, it's not going to have internet for when you plan to use it. I apologize, my screen looks like it has gone to sleep here, so hopefully the video didn't just cut out. But yeah, so that's kind of the concept behind it. Line of sight, more or less, it spreads out like your flashlight, so it covers a greater area. Anything within that area is going to get it. So it'd give you super high bandwidth, so you could have some ridiculous internet speeds for your Wi-Fi, similar to what you'd have as if you had a fiber optic wired connection into your phone, is more or less what you'd be experiencing. So for gaming and stuff like that would be incredible. But say you want to go somewhere else or have your setup or something like that, like I have a computer over here and a computer up top, I would have to have a receiver pointing at my light or my transceiver that emits this in near infrared light, and it can become quite a nuisance. So it never really took off, and I'm assuming that's probably why, and probably due to costs as well. However, you can experiment with this, and this brings me to the OpenAI ChatGPT exercise I wanted to try with everybody. So I'll talk through it so those that are listening can see what I'm doing, but this is a good way and a tool to learn things. So this is what I was talking about. So you can use AI to be a tool to teach you many things, but with great power comes great responsibility. You can't become complacent. And this is what I've seen already in the short time that AI has been around, especially when it comes to interviewing people for roles at jobs and stuff like that. I really encourage people to really understand what they're doing or what the AI is outputting. And if you don't understand what it created, ask it questions. It will provide some pretty significant in-depth, descriptions and reasoning behind why it did what it did, which is kind of cool. So I want to go through that with everybody that's watching, and I'll talk through it for those that are listening. So the example I want to use is kind of what I mentioned with the near infrared, or an IR, an actual infrared diode or light emitting diode, and a receiver similar to what you'd see on an older television, and your remote control. You can build this at home for pretty cheap, and you don't even need to know how to do it. AI can walk you through the entire steps. It can tell you what you need to buy, where to get it, what it's going to cost, how to build it, how to wire everything, and then it'll even give you all the sample code you need to run this thing. And you don't know how to load the code or anything like that, it'll go through the entire thing. It'll create you an environment. It can do absolutely all of it for you. That's the danger. When people do this and they say, I'm not going to write the code myself, I'm going to have AI do it because it's going to save me time. The more times you do that, you forget how to do it yourself. Coding is definitely a perishable skill, and technology is changing so fast, especially programming. And new languages are coming out, new technologies, new libraries. If you don't stay up with the syntax and how it works, you won't really remember how to do it as time goes on. Think of it like a language, a spoken language. I did French in high school. Do I know much French now? Probably not. Now I know enough to get by, and once I start talking, it'll come back. But not enough to pass the same tests I had to when I was in the military and did my second language training. You have to stick with it. So what I'm trying to say is AI is great, but definitely take the time to really understand what it's creating so you don't lose the ability to do this yourself. It might be neat to go and write your own code first and then pass that to the AI tool and say, hey, how does this code look? What would you improve? And then use it to teach you in that way rather than having it doing it all from scratch for you. But the purpose of this exercise is to show you just the opposite. This is how you do it all from scratch using AI and not doing it yourself. So we're going to start with a simple prompt here. And a prompt is just a text description of what you want the AI to do. So we're going to say, tell me how. Tell me how to build an IR, so that's for infrared, transmitter and receiver using two Arduinos. And Arduinos are little microcontroller boards that are close to being embedded programming. It's not truly embedded programming, but it simplifies it for people. So if somebody says to you, oh, I do embedded programming, and then they say, oh, I use an Arduino, they're close. So maybe I'll give it to them. But really embedded programming is like working on like an STM32 or something like that. An actual like PIC microcontroller, that's embedded programming. This takes all the fun out of it and does a lot of it for you under the scenes, but it's a great way to learn and kind of intro into it. So that's why I'm using these, because they're cheap to purchase. You can get some of these for, you know, under $10. They have a lot of peripherals that you can get for them, and a lot of tutorials. They are probably the most common microcontroller programmable board that you can get that's out there today. So that's why we're using this one. So what did I say here? Show me how to create an IR transmitter and receiver using two Arduinos. Please provide all the code needed to test this out and how to build this from scratch. Provide a list of parts needed. All right. We'll keep it kind of vague here, and let's just see what it gives us. So in real time, here we go. So to build an IR transmitter and receiver using two Arduino boards, we will be utilizing infrared communication. The idea is to use one Arduino as the transmitter and the other as a receiver, sending and receiving signals via infrared. So this is very close to what that laser system of DSOC would be. You have a laser transmitter and a laser receiver. Now you could put a transmitter and receiver on one, and that becomes a transceiver. And then you would build two of those, and they can send to and from. The one we're talking about right now is one transmitter, one receiver, meaning one-way communication to the receiver. Just to clarify on that one. Now you can definitely do transceivers in that just as simple as this. You just kind of build out twice as many things here. So the components needed, you need two Arduino boards. Here it specifies Arduino Uno, Nano, or similar. There are knockoff ones you can get on Amazon that, as I mentioned, are $10 or less. But these are the ones that the AI has recommended. You need one infrared LED. This is for the transmitter. And one infrared receiver. And it gives you an example, a TSOP 38238 or similar. That is the receiver, I guess, code. That's the actual product ID, not product ID. What's the word I'm looking for? That's the component. If you search that up, you'll see the component you need. Having a brain fart here. All right, you need two 220 ohm resistors. This is for limiting on the infrared LED so you don't burn them up when you're doing your transmitting. And a 10K ohm resistor. This is for pull-up resistors on the infrared receiver. What this does is adds a voltage pull up on the signal that just gives it a bit more power on the receiving end, kind of amplifies that. You then need jumper wires, breadboard, two 3-pin headers for the infrared transmitter and receiver connections, one 100 nanofarad capacitor. This is optional and it is used for noise reduction. What this does is it kind of smooths the signal out so you don't get choppiness in there. That would be noise. And last but not least, we need one 38 kilohertz infrared remote library for the Arduino. The library that it's referring to is going to be what is used in the code itself, and that's pretty much a toolkit for when you write code that gives you a bunch of pre-built functionality that you can then use in your code rather than writing it all from scratch yourself. All right, steps to build the IR transmitter and receiver. So I'm not going to read through all of this. I just wanted to show you what is capable with this tool. So it gives you the wiring of the transmitter, wiring of the receiver, tells you which one's part of Arduino 1, which one's part of the second one, the libraries needed. Here it mentions download iRemote for the Arduino. It probably thinks we're building a remote control for, say, a TV. You can really do this for anything. You could control a robot with this. Again, it's going to be more or less line of sight, but you have an angle that this is going to cover. So think of like a pizza slice, anything that falls within that pizza slice in front of the controller or the remote itself, that transmitter, will then receive that signal. And here's the code, and it gives a C++ example, which is super cool. Usually it gives me Python. You can specify if there's a certain language you are learning or would like to learn. You can put that in that initial description that you provide to the AI, and it'll run you through that as well. Then it gives you the code for the receiving side, tells you how to do your test setup. If there's any issues, this is how you troubleshoot it. Then it gives you optional enhancements, which gets into kind of what we were talking about with the DSOC network and what they do, where you modulate the signal, you put in error correcting code. You can also add power supplies to these things. You can change this from infrared, you can move it to laser, you could play with optics and really focus these beams and see how you change your band of influence on them too. There's a lot of cool things you could do, but I really wanted to show you this is what you can do with AI. It's a super powerful tool that really is out there for everyone to use. This is, I didn't even log in and it still gave me all this, so you can definitely do this for free. You don't have to pay for any subscriptions on any of these AI platforms, and maybe we'll do an episode just on AI in space and robotics and stuff like that. Again, we talked a little bit about it in one of my earlier podcasts that I did, but now that we have video and do a different form of podcast here, it might be a bit more fun to get into it and talk things like Robonaut and all the different robots that are out there right now, and how AI is now influencing and training them, which is super cool. But yeah, so that's kind of where I'm getting here. But I hope this was enjoyable for everyone listening here, and for those that are watching. Definitely let me know if you're listening to this. Is this effective? Does this give you enough that you enjoy it? For those that are watching, same thing. Like, let me know how I can make this better for those that are listening and watching. And yeah, maybe the next one we'll do on AI. It could be a lot of fun. But I don't want to go on too much longer. I think I've been talking too much here anyways. I hope everyone enjoyed this, and stay tuned. Definitely subscribe, follow along, turn on notifications, all the fun stuff. Click wherever you got to click. And I hope to see you or have you listen in on the next one. So definitely stay tuned, enjoy, and don't forget, stay curious, keep looking up, and off to the next one.